Okay, hello guys, and welcome to the second chapter of my free YouTube course on learning Java. And today we will talk about variables and constants. This will be a pretty short video. We finally get to start coding. And first I want to introduce the distinction between variables and constants on like a conceptual level, and then we'll start programming. Okay, so what is a variable? We know variables from mathematics, for example. And just as an aside, you can ignore what I'm doing here. You should be familiar with this. We're just declaring a class, okay? You can do this in IntelliJ on your own, I hope, to just create a Java class. If not, you can ask in the comments and I'll explain it to you. And this, you can either do comments on one line. Okay, this is a comment, but this isn't. Okay, so this, with these two forward slashes, you create a comment. You can comment, but just on one line. And by using this syntax, you can have multiple comments on multiple lines. Okay. So variables, what are they? Of course, we know them. For example, in mathematics, where this x is not a concrete value, okay, but is a placeholder for any value in a set. Okay. Usually we let this be implicit, okay, but implicitly what we mean is implicitly you can pick out any number out of a set S. For example, the set of all real numbers are, and substitute that number for x. Okay, this is what we mean when we talk about variables in mathematics. So they introduce a certain an aspect of generality to your statement. Okay, so this is a general statement. If you have, for example, Pythagoras theorem, which states that a squared plus plus b squared is equal to z squared, where a and b are the I don't know the English expression, but this is the hypotenuse, and these are the two other sides of a triangle, you know what I mean? And by not writing any concrete number here, but just like this variable, we mean to say that this holds for any a and b, and c you choose. Okay? So this should be pretty clear. This is just like, we know in mathematics we know variables because we get introduced to algebra. But of course in programming this is a whole nother topic, okay? In let's say computer science, we can think of a variable as being a box in which we can put values, okay, or simply stuff, if you want to have the metaphor in a like general way, okay. So imagine having a little box, and you can put values into that box, okay. In the intermediate, in the following videos on the intermediate learning levels, I will actually talk a little bit more about the technical details. We'll talk about how variables are stored in memory and how you can change the values of these variables, what happens when you change the values of these variables in memory. But for now, we can simply think of them as being a box we can put stuff into, okay? Let me give you an easier comparison. For example, in Python, you can write stuff like a equals to 10, okay? You don't even have to do the semicolon, and this is a valid variable declaration, okay? It's a very important concept, variable declaration. You can do this, and it's obvious. And this is why we call it a variable, because a variable is a box in which you can put values, and you can also put take stuff outside of the box and put a new value in it, okay? So the content of the box can change, the value inside the box can change. So we could do something with a right here, and then on line, let's say 7 of our program, we can write a 5, a is equal to 5, right? And this is what we call reassignment. This is not how you spell reassignment, I think. Reassignment, yeah, that's how you spell it. So this is possible in the case of variables. We have a little box named a, we put a value into this box, in this case it's the value 10. And further on in our program, we can actually reassign a value. So we put the 10 out of the box and put the 5 into the box, and we are fine, okay? And this is the central distinction to constants, okay? Let's say we have let's look at this in pseudocode. And pseudocode is just, this is not any programming language, but it's just like an abstraction over programming languages to tell you what's going on. Many languages, you can specify what you are doing by, for example, writing constant. This means constant, okay? Let's write down constant for now. Then we give it a constant name. And then we say it equals to, let's say, 42, for example, okay? This is a keyword in this pseudocode, which simply means what we are declaring here, okay, is not a variable, it's a constant. And the only difference in that respect between constant and variables is that the content of the box is simply constant. You cannot change it. You can't do reassignment, okay? For example, if I would write const a equals 42, okay, in some language, where this simply means we declare a constant with the name a, and we give it the name 42, okay? So this is also like a box, but once you put something into that box, you cannot change it, okay? So we cannot do something like we did before, where we write a equals 32 for now, okay? So we simply cannot do this because a is in constant. Yeah, that's, I think, the use cases of constants pretty obvious. If you want to store like some physical constant, for example, the speed of light or gravity or whatever, it's usually good to put them into a constant because these values shouldn't change in your program. Okay, as soon as you have like some simple constant value which you don't want to reassign, maybe because it refers to a physical constant or it refers to some information which is constant in your program. For example, if you program a game, let's say you want to program a chess game, of course you know the dimension is 8 times 8, okay? And you can make these constant, because if you don't make them constant, some people could change them, and this is not what you want. Chess is played on an 8x8 board, okay? So there's 64 squares. So this is what I think the use case of constants is, and there's a convention which is pretty important. Write constants all uppercase. Okay, write, for example, const pi or speed of light or something, but write them uppercase. And in a variable declaration in Java, so there's a further convention. In a variable declaration or any other statement or any other naming or any other name you give some entities in your program, use camel case. Okay, and this is how you do camel case. So you start with a lower letter, and then you, as soon as the next word starts, you write it in uppercase. So for example, if I would write something in a business logic and it would have receipts, stationary treatment. This is how you would name stuff. Except for classes, and then we'll start talking about convention, because classes should always be like this. So you start with an uppercase, and as soon as you want to write another word, you also put the first letter of that word in uppercase, okay? It's unusual, but of course you can do it. Every convention is arbitrary in a sense. You could also do this or this, but I wouldn't recommend it. It doesn't look good, and people programming in Java aren't that into it. Okay. Now I want to introduce you and give you a very important distinction. This is the distinction between dynamically typed programming languages versus statically typed programming languages. Okay, what do I mean by that? Let me elaborate. Python is a great example for a dynamically typed programming language, JavaScript as well. So these are more highly abstracted, you could say, simply because they are dynamically typed, and you can think of C, C++, Java, and many other programming languages being statically typed. Okay, they fall into this category. Let's think back to our little Python program. Okay, in Python, you could do this. Okay, you could, for example, write hello world string equals hello world. Then you can print hello world string. I keep doing these like semicolons because I come from Java. I'm sorry. I actually think you can put these semicolons right there, but it doesn't matter. Of course, since it's a variable, you could reassign a certain value, a certain string in that case, hello world, for example, and then you could print it out again. Doesn't matter. But the interesting part about Java and any dynamically typed programming languages is that you don't have to specify the data type of this variable or constant. Okay. For now on, I will only talk about variables because they're more important. But the same applies to constants. The same distinction applies when declaring a constant. Okay. Of course, you're not familiar with the concept of what a data type is, but let me show you how this is done in Java. Okay, I'm back, and I realized I'm an idiot because you obviously have to define the entry point of our program. This should be obvious. Sorry, I forgot that because I got carried away with explaining all this stuff. And now we should be able to actually print out the number, but first we have to declare it. Okay, so this is your first variable declaration in Java, and we'll do a very simple one. We simply declare a variable we call num, and we give it the value of 42. Of course, we have to spell it correctly right here. We can run this, and you see we print out 42 to the console. So everything was correct. But what you can't do, and this is why we call Java a statically typed programming language, you can't do stuff like this. Okay, and you'll get an error by the IntelliJ IDE. Cannot resolve num. Create local variable num. And now you see you have to specify a data type. For now, ignore what the data type is, but you have to say, okay, this num is either an int, a long, a float, a double, or anything else. Okay, so you have to specify the data type. So the syntax for a variable declaration in Java is always data type, variable name, assignment operator. Okay, we call this equal sign here the assignment operator, because with this operator we assign a value to a variable with a certain name and a certain data type. And we say data, and then here we'll insert a value that fits the data type. Okay, that's very important. Value that fits the data type. Now you obviously can ask, what are data types? Okay, and I gave you this like metaphor of a variable as being like a box, and assigning a value to a variable as being like trying to put something into that box. Okay, but now imagine that if you want to put something into a box, you also have to have an object in a fitting form, because let's say the top of the box where you have to put things through, okay, it's shaped in a certain form. For example, it's shaped like a cross. So and if you want to put in something that is shaped like a ball, for example, it simply won't fit into that box. Okay, so hopefully the metaphor is somehow useful to you. But what I mean by this, you have to specify in a statically typed programming language what type of data, okay, you try to assign to the variable called none. Okay, so what data types are there? This is like a natural follow-up question, right? What are data types? How many are there, maybe? I think we have to. What are they? How many are there? And how are they used in a variable declaration? These are questions you could ask. Okay, we already answered this question by giving you the general syntax. So whenever you want to declare a variable, you first have to specify the data type, then you give that variable a certain name, then you use the assignment operator, and then you specify a value, and then you end every statement with this semicolon right here. But what are data types? And like the trivial answer to this question is simply types of data. Okay, where the important concept is the data. And in computer science in general, we try to represent real-world data, right? We try to represent numerical data. Okay, this is like a subset of data. There's also, of course, non-numerical data. Think about, for example, the string "hello world" we printed out. Like this is in the end, it's just a collection of special characters which are not non-numerical. For this H, this E. Yeah, of course, there are many others. For example, one single character could be, for example, also a hashtag. Also note that I use double quotes here and single quotes here. This is important. I'll explain it further on. So we want to represent this, okay? And so let's maybe go step by step and first think about numerical data, okay? You might still remember from high school that we have the whole numbers, okay? We call this the set C, just like it's called in mathematics. And this is simply from -1, from, let's say, negative infinity to -1, 0, 1, up to positive infinity, yeah? And these numbers, these simple numbers, we call integers. Or, yeah, for now we can simply call them integers, okay? In computer science, yeah? Of course, if you know a little bit about how computers actually work, you probably also know that in the end, everything we try to represent has to be represented in a stream of binary data, of on-off signals or high voltage, low voltage signals. So of course you won't find the number, like this number, written down somewhere on the register in the CPU, for example, and then the computer knows this number. No, this is when we take an element of set, for example, the number 3. Okay, just to give an easy example, we talk about this number in the decimal system. Okay, and this represents to, for example, if we take a 4-bit number, to this string of on-off signals, so to speak, because in the end, what's happening when the central processing unit loads data from a register is simply that a stream of on-off signals is sent to the CPU so that it can execute it. And we can map these on-off signals into this binary system. And by using this binary system, we can represent any number in any number system, okay? On the intermediate level, I'll get into the mathematics of how these different number systems work. It's actually pretty easy. But for now, it should be clear that we call every time we try to assign a number out of this set to some variable in our program, we have to specify an integer, just like we did here, because obviously 42 is an element of that set. Okay, that should be clear. Obviously, in the end, the computer, the CPU uses a stream of on-off signals, which we map into which can be mapped with a binary system. But these are technical details I'll get into more in the intermediate learning level. But we know from high school that there are not only the whole numbers, right? There's also the set of the rational numbers, which is often called Q, okay? And the definition of this is a little bit more cumbersome, but let me write it down. Of course, it's not that important that you know these definitions, but okay? It's simply the fraction A divided by B, where A is an element of Z, okay? And B is an element of Z, and B is not equal to 0, okay? I represent not equal like we do in programming, like here. Okay. It should be pretty obvious that in mathematics you can represent any of these numbers in, you can find any of these numbers just represented differently in the set. For example, the number, let's say 2 is simply 2 over 1, right? So it's actually pretty easy to show that Z is a real subset of Q. But the important thing is there are many numbers in Q which you cannot find in Z, obviously, okay? Just to give you a very trivial example, the number, let's say 1/3, okay? Equal to 0.33 and so on, for going on forever, you won't find in the set right here. And even in that sense, even in mathematics, the members of this set are of a different type of like the members of these sets. Okay, so these are what we could also call these like simple fractions, so we don't get too technical in whole numbers. So even in mathematics we find a distinction, and this distinction becomes very important when we do programming. But first let me tell you what we call these fractions, these numbers with like decimal parts. Like we simply call them floats or floating point numbers, or in Java we could also call them double. Okay. And you can, and I don't want to get too much into the technical details because we're still at the beginner learning level. I'll talk about the standard IEEE 754. It is, I think. Okay. Hope that's correct. If not, I'll make an annotation in the comments. But you can understand immediately that these numbers get stored in memory differently. Okay. And this is because even the processor has to compute them differently. In some processors, there's even a floating point unit, okay, which does like these floating point arithmetics, and this is very complicated. Division is a very costly operation in programming. So for now, it's just a big question mark how they get stored in binary, right? I'll talk about this in another video that I still have to upload, but once it's done, I'll upload it here. But for now, simply realize that a fraction is different from a whole number in mathematics, but also in programming. In programming, because it gets stored differently, the process of like translating this number we know 1/3 into a binary number in memory space is different, and the way this number has to be processed by the CPU is also different. And this is the reason why we have broadly speaking, two different numerical data types in Java. And this is simply a whole number, something like an int, and a decimal or fractional number. You can call them any way you like. Okay, fractional number, floating point number, whatever. So I gave you an example of two different data types. Okay, so let's get into the syntax right here. Once again, remember this general syntax is always we specify the data type, we specify the variable name, we write this little assignment operator and we give it a value. And let's try something which obviously shouldn't work. Okay, like int frac num equals to 0.33, example. Yeah, and you see the compiler is annoying. It says, hey, you required an integer. You said this little box right here only takes in integer, okay, whole numbers, but you are specifying a double right here. What are you doing? This makes no sense. But if we write double, okay, we see it works out just fine. Can of course print it out again, so maybe it's not that dry. My presentation, you see, it's 0.333. I could go into much more detail when it comes to floating point arithmetic and how these fractions get stored in memory. It's actually pretty interesting, also pretty technical. But since this is the beginner learning level, as I already said, I won't do it. So what we learned right now is the difference between these two data types. Okay, let's call this whole num and give it a value of 420, for example. So we told you about these two different data types. Now the stuff gets a little bit more complicated because there are also shorts and longs, but it's not that much more complicated, because maybe let's just explain it. I previously told you that the number 3, for example, is represented in binary as this number. Then you could ask yourself, wait, but aren't these like zeros superfluous? You don't need the zeros right here, right? But you have to think, every single little digit right here, okay, is a bit. So what we are specifying here is a 4-bit 4-bit binary representation of 3 in decimal. Okay. Of course, in Java we don't only have 4 bits if we want to represent integers, because yeah, maybe I asked you, maybe you can pause the video. What is the maximum value you can store in a 4-bit number, in a 4-bit in these 4 bits? Okay. And remember, these are not just the positive whole numbers; these are also the negative whole numbers. Okay. So I'll give you some time to pause the video, and then we can. Okay, I'll show you now. If you think about it, so you see 3 is represented in binary like this number because we have specified only 4 bits. Okay. And 4 bits, if you think about it, there are like, for every one there are 2 options. It's either it's a 0 or it's a 1. So we simply have 2 to the power of 4 possible combinations, and this is how we actually map into the integers. So this is 16, okay? But we don't only want to represent the numbers from like 0 to 16. Even then we couldn't do it, because 0 is a number that has to be assigned to one of these possible combinations, right? So 0 is simply 0, 0, 0, 0. But you have to actually divide it by 2. Divided by 2, you'll get 8, and then you can go from -8 up to 7, okay? So this is obviously only 15, but you always have to think there's still the 0, okay? So this is the range which you can represent with 4 bits, okay? Which is very, very little. So you want to, so by default, an integer is of size 32 bits, okay? So you see this is way bigger. You can represent way bigger numbers. Maybe we'll do the math once again. So what is 2? And this is where I obviously have to use a calculator. 2 to the power of, okay, this is not working. 2 to the power of 32. I'll have to look at Obsidian. Not at Obsidian. I have to Google it, I mean. 2 to the power of 32 is this sweet little number right here. Okay. We do the same stuff. We divide it in half. So, Yeah, should be pretty obvious, but you have to divide it by half. So if we do this divided by 2, it's equal to this number right here. And then you always have to subtract 1, because we have to represent 0 as well. And this gives us 7. And if you don't believe me, you can actually Google it. Max value integer, 32-bit. It's 214,483, exactly what we wrote here. So you can see it's pretty neat to be actually able to specify the size of the data and not only the type. We specify the size of the data simply by specifying the type, but this is something the Java language does for us, okay? The Java language simply says, okay, this, if you declare an integer, it's by default a 32 bit, so you can represent at maximum this number right here, okay? Maybe if I give you an example, but and this is how you should learn programming, you should play around with the idea. So what would happen if we try to store a number that's bigger, okay? So we have this number right here, which we can actually store. We increment it by 1, okay? And you see the IDE already annoys you and says this integer is too large. But you can still try to compile and print it out. Let's print it out, this bigger number right here. You see, you get a compilation error. This is simply too big. But if you subtract by only 1, you can actually print it out. Amazing, isn't it? And now you can have a more fine-grained control over size of whole numbers, and this gives us different data types. Okay? If you want to represent, you want to represent a small whole number, you can simply write byte, really small num, and let's say this is 2, yeah. But a byte is only 8 bits. 8 bits. This is simply 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So for every one of this, you can think about the max the same way. I'll do it. I won't do it again. And maybe just to illustrate how to use ChatGPT. Of course, I know the stuff, but if you don't know, you could simply ask ChatGPT different whole number data types Java byte, short, int, and long, and then you can find that this is, as I told you, 8-bit. A short is a 16-bit. Int is a 32-bit, and a long, which is usually nowadays, because we have so much memory, we don't really use these data types, to be completely honest. Of course, it's good practice to actually use them if you are sure that you only need to store a very small number. But the long data type is also very interesting, but maybe byte, just for, so it's complete, short, small, num, 32, and then we have the regular integer, normal, num, let's say, and then we have the long, really big num, okay? Remember, this is the maximum of an integer, and if we increase it by 1, we can still store this in the long data type. Right, sorry, I keep forgetting this is very embarrassing, but you have to specify, because this is also a very interesting point, and I should have remembered this, obviously. If we want to specify, if we want to declare a number, because this gets casted to an integer just by default, so you have to specify that this is, the compiler should treat this as a floating point number by writing this uppercase L at the end. You see, I don't really work with these big numbers, so I usually work with it in a different way by reading it in from a database, for example. So I forgot this. You have to specify the L at the end, okay? And once again, just to give you an example of how to use ChatGPT, declare every whole number data type in Java for me. Then you can see how it's done, and of course ChatGPT is smarter than I. Have to remember that it should specify this L right here. It's a long literal to avoid any potential compilation errors. I think it's pretty bad that you are actually forced to write this. The compiler should do this on its own, but okay. But in the end, byte, short, long, you can forget about it for now, because the really important distinction is between the whole numbers, how the whole numbers are stored in memory, and the fractional numbers, okay? And what we talked about right here are simply the whole numbers. But let's go to the representation of fractional numbers in Java, okay? So let's make this clear here. Let's talk about whole numbers only. Now let's talk about fractional numbers. Okay. First of all, there's a tip I give you that everyone gives you. Only use doubles. There are actually the data type double and float are available in Java. This is a 32-bit. This is a 64-bit number. But especially when it comes to floating point arithmetic, it's very important to have a high amount of precision. And so it's generally advised to just use these doubles by default. But just to give you like an idea how to do this, let's say you want to double frac num2. I think I already declared a frac num somewhere. No, okay. This is also something I should have told you. You can't declare two variables with the same name. It should be obvious, but yeah, it's already in usage. Okay, it's already defined in the scope, so you can't do that. Simply, okay. You can obviously store an integer in a fractional number. It's not a problem. So this will, but usually you write it something like this. Yeah. You can, of course, fractions are in the end outcomes. Fractional numbers are outcome of divisions, right? You can think about it that way. You can also write 1/3, for example, but you get an interesting error if you do it like this. Yeah, and this is where an IDE comes in very handy, because it tells you, wait a minute, and this is what the problem I had right here as well. These two numbers are interpreted as being of type integer, Okay, so this is so this division operation is done on integers, and we don't want that, because if you simply print out 1/3, can't see anything. Okay, let's where are there? Okay, let's stop printing this because it's confusing me. If you print this out, you get 0.0. Okay, what happened? Obviously, this should be 0.333 going on forever. Of course, not forever, depending on how much digits there are available, how many bits, the size of the data type, right? But what happened here is this: the compiler interpreted this as an operation of division on simply the integers, and then it's because you can only get an integer from an operation like that. It simply divides 1 by 3, and it truncates all decimal places. Okay, so you have to cast, and typecasting we'll talk about in another video. But for now, simply write the double 1/3. Now we run this little program again, and you actually got the correct answer. And this simply tells the compiler, okay, we want to do this division operation on this double here, okay? So the decimal places don't get truncated. What happens here on a more technical level, I'll talk about on the intermediate learning level, but I just wanted to give you this hint right now, okay? Just to be completely sure, to make it complete, I also show you how to declare a floating point number, declaration floating point number, and this is simply float num, and there you also have to specify this little ledger at the end. So, but in general, it's advised to simply stick to floats, to doubles. I mean, sorry, when dealing with fractional numbers. So I'll just delete, or maybe I don't delete it. But generally advised, don't use float, use a double instead. Okay, I realize this video is already getting pretty long, but this is, I know it's also a pretty dry topic, but you have to learn the basics to actually do interesting stuff in the future, so I hope you stick with me. So what we learned right now is the difference, so we talked about data in general. We distinguish between numerical and non-numerical data, could also call this maybe categorical data. Inside the class of numerical data, there's a distinction which you can find in math between, for example, in math, where the whole numbers and the rational numbers is an important distinction. This distinction is very important in computer science as well, because they get stored in memory differently, because, yeah. As I said, I'll explain the details on the intermediate learning level. So, and then I showed you the general syntax of a variable declaration as simply data type, variable num value. And since we have to distinguish between whole numbers and fractional numbers, we specify this as being an int, because this is obviously a whole number. It's inside of that little set right here. Then I showed you how to declare variables with like fractions. The floating point numbers, I told you to only use the double, because the float can lead to imprecise calculations. And then I also showed you, because just to give you the facts on the matter, a floating point number is a 30-bit number, a double is a 64-bit number, so it's double precision. And then I also showed you like these sub data types of the whole numbers, which are simply with which you can simply have more control over the size of the binary representation. So this is 8-bit, 16-bit, 32-bit, 64 bits. Okay, I know this was a lot to take in, but this is obviously not all, because we only talked about the numerical data, right? So there's also non-numerical data. And I'll do this one pretty quickly, because it's, of course, it's also interesting and important. But yeah, for now, let's think about one little symbol, okay? Let's think about A, for example, okay? A, we can simply declare a symbol like A. We call this a character, important word. A simple single character by simply writing jar for character, jar A, for example, and we'll give it the value of A, okay? So this is obviously something completely different from what we talked about earlier, because we don't talk about numerical data anymore. And on the intermediate level, I'll talk to you how this is actually represented. You can already guess that somehow the symbol right here has to be represented numerically. But for us as programmers, we can abstract away from these technical details of implementation and simply realize, okay, this is a whole other thing than a number. Okay, this is simply a single character which we want to use. Let me show you something funny, actually. You can do maybe let's uncomment this so we don't have to bother. You get a B, so you can actually increment this, and by yeah, you can see this is something we can call method operation overloading. This plus plus obviously works way different than if I would write frac num plus plus, for example, right? Okay, frac num plus plus simply means add 1 to it, okay? But if I add 1 to this, I'll get the character B, okay? But simply because we can increment it, you can already guess that under the hood there's a numerical encoding of these character values, and you can actually play around with it. But for now, maybe this confused you, I'm sorry. For now, simply realize there's a single quotation mark right here, and you can put only single characters, and a character is always an atom, so to say. It's a single thing, okay? And now let's talk about maybe the easiest of all data types. This is a Boolean, okay? And the Boolean is simply a truth value, so it's either true or false. So Boolean, bool value, let's say, is true, or Boolean bool, or let's call this not bool value, let's call this bool true, call this bool false. And these are all the possible values Boolean can hold because it's simply a truth value. I think it's either true or it is false. Okay, there's nothing in between, only in computer science and traditional orthodox logic. Okay, so yeah, this should be pretty easy, and you can think of a Boolean as simply being 1 bit. Yeah? I think under the hood it's implemented that Boolean is bigger than 1 bit. I don't really know why, to be honest, but it's either true or false. Okay. Okay, let's circle back. I showed you the syntax of variable declaration. Okay, I specify. You need to specify the data type. You give your variable a name. You use the assignment operator, and you stick a value into that num box, that fits the data type. Okay, so I can write something like this, for example. This should be clear right now. It should also be clear that Java is a statically typed language, simply because we have to specify the data type all the time. Then inside of the class of numerical data, we made a distinction between whole numbers and fractional numbers. These are different data types in computer science, even in math. Okay, so we write in whole numbers like this. We declare an integer. We can also have more fine-grained control of about how much space in memory this variable actually holds. So this is 8-bit, 32. I showed you how to actually calculate the max values that these, for example, a 32-bit binary string can hold. I'll talk about this in more detail on the intermediate learning level. I'm sorry, I didn't want to do that. Oops, what's going on? What is going on? Then we talked about floating point numbers, which we call double. I also showed you how to use how to declare actually a variable of the data type float, but it's generally advised to simply stick to doubles. Then I showed you non-numerical data. This is the first. I showed you 2 examples. First of all, they are characters, single, little, let's say, symbols. Okay, this could be a, this could be a hashtag, this could be anything. The only important thing is that you actually specified the value of this character variable inside single quotes. Okay, single quotes. This is important because okay, let's just try what happens if I don't do it. Because these double quotes signal the compiler that I want to assign a string. We'll talk about strings in just a few seconds. And then there's the easiest of all data types, which is simply a Boolean. And a Boolean is a truth value, so it can hold either true or false. Yeah? And all these different data types, okay, are what we could call primitive data types. Okay, let's specify this right here. Primitive data types. Data types. That's indented, maybe even more. Okay, so what is this distinction between primitive data types and complex data types? You should probably call them data structures to make this distinction even more clear. And this is something I found really weird when studying like informatics. People can't somehow actually be conceptually precise when talking about stuff, because some people call like strings. If you declare a string, for example, if you do string example equals to hello world, for example, do this. They still call this a data type specification, but this actually specifies what I would call a data structure, just to make this distinction between primitive data types and complex data types a little bit more pregnant, a little bit more clear. But in the end, the distinction should be pretty clear, because let's think about a complex data type. A complex data type is always a sort of collection, okay? You can think about this little string example and notice the double quotes, because now we actually try to assign a string to that variable with the name string example. And of course, this is this value consists out of a more simple data type, a jar, one could say. So in the end, a string is a jar array, okay? So it's a collection of, you can think about it like this. It's a collection of single characters, just like concatenated. But technically speaking, this is not quite correct, but you can think about it that way for now. And so on and so on, right? So a string is already an example of a complex data type of a data structure, because it's a collection of more primitive data types, okay? And just by inference, this means a primitive data type is not a collection of out of anything more simple than itself. Okay, so in that sense, a primitive data type is like the most simple data type. It's like in computer science, it's like the concept of an atom. Okay, so it can't be broken down into more basic stuff, whereas the complex data types like strings can be broken down into more simpler data types like characters. Okay, yeah, we won't talk about complex data types like arrays or lists for now. This is also only on the intermediate learning level, because we should stick to the simple part for now, to the primitive data types, right? But I talk about strings just to give you already an example of a complex data type, or probably you should refer to it more than the data structure, okay? Just because we want to use strings a lot. Okay. Hopefully this was all clear and you didn't get too confused, but if you don't understand everything, if you don't understood everything I told you, don't worry, we will practice a lot. Yeah, and in the next video, we will talk about operations on data, okay? I already showed you this little funny trick where I incremented this jar character by 1, and then b was displayed, and the value of jar was still a. But yeah, this is the next step we can logically do, okay? Now we know how to represent data in a computer, but we don't only want to represent data, we want to do operations on data. We want to, for example, add numbers, we want to concatenate strings, stuff like that. All right, hopefully I didn't lose you, and hopefully we'll see us in the next video. So bye-bye.